Okay, it works. Okay. Good morning, everyone. I see people are still coming back from the fire. I'm not going to wait. I'm going to start. Okay. Hello, everyone, and welcome to my talk. I must admit, all this evacuation caused a lot of stress to me, and stress is not good for your memory, especially short-term ones. So I completely forgot what is in most of the slides. I'm going to use that as an excuse. Also, I have a very severe case of slide edidis, which means I'm constantly adding slides even 5 minutes before the talk, and there is never time to finish all of them. So it's not going to happen today. It never happened before. That I cannot blame on fire. Okay. My name is Slava. I work on the Dart team. I am overall technical lead for the Dart team these days. So if you have any questions about Dart, future, or have suggestions about the evolution of Dart and so on and so forth, come catch me. I will try to run away. If you manage to catch me, you get your chance to ask a question. I will answer it truthfully. Okay, so without further ado, no, actually, like, you know, when you do talks, you always need to start by telling some story from 20 years ago or so. 20 years ago, I was already pretty aware of the fact that I would be a programmer and I could program some C, and I wanted to level up my game. So what do you do 20 years ago when you want to level up your game? Well, you go to the bookstore and you buy a book. So I went to a bookstore and bought this book with 400 pages, and I never got past the first 50 or so. Did not stop me from becoming a better programmer, though. But on this first 50 pages that I managed to get through, there was one thing that really caught my attention and stayed with me through all these years. It's this quote in the foreword to the first edition of that book. It's a quote from Benjamin Lee Worf, who was a linguist. And he said, "Language shapes the way we think and determines what we can think about." And somehow it really stayed with me. And I constantly return to this phrase. I think that's what maybe got me into the programming language development to begin with. I'm not sure, but now if I look back, maybe that's the thing. This is something known as the Sapir-Whorf hypothesis, or linguistic relativity. It postulates that the language that we can speak, it impacts the way we perceive reality. So if you speak Swedish, your perception of reality is different from people who speak, I don't know, some other language like C++. Anyway, so I think there is actually truth to it, because the way programmers approach things is very based on the fact which programming languages they know and have experience with. So there is something true to it. The whole thing is quite disputed, and it's called hypothesis, not a fact, but still, I thought it's an interesting thing. People, though, realized it way before Worf. Worf lived like in 20th century, but 500 years before, there was a guy called Charles V, the Holy Roman Emperor, who said this, that he speaks Spanish to God, Italian to women, French to men, and German to his horse. I guess, yeah. If you translate this to the modern language, then if I go now into the, like, between the rows and start asking you, I probably discovered that you speak Dart to your mobile apps or your mobile phones to create an apps, and your backends are written in some other programming language. It's just a modern version of this thing, and I think it's wrong. And when you go to some social media platforms and read the threads about Dart, you discover a lot of people who say, well, I have discovered Dart through Flutter, and I really love it, and I have created many apps with Flutter, but my backend is still trusted Node.js version 0.6 because it's just the best thing since sliced bread. And it also parses JSON 1,000 times faster, according to this post I found on LinkedIn. Usually I get upset about things when I see this. Mostly I get upset about the jsonDecode being so slow, not about the fact that people use very strange arguments to choose what to develop their backends with. But anyway, let's take it as a face value. and try to figure out, is this nasty JSON decode actually slow, and what can be done about it? So first we need to figure out what we are comparing, right? The guy on Reddit, that was actually a fake post, which I created using the Chrome DevTools. Don't try to find it. But anyway, so that hypothetical guy, which is kind of an average of all Dart developers on Reddit who don't like developing server-side Dart, he compares JavaScript like Node.js versus Dart. So what do we have in JavaScript? Well, in JavaScript we have this JSON.parse thing, which you give it a string and you get back a JavaScript object or array or primitive. In JavaScript engine like V8, it's usually written in C++. You can go read an implementation if you know C++. That's where that book from the beginning comes quite helpful, if you can get through it. In Dart, the story is a bit different. You have this jsonDecode method. You give it a string. You get a map, a list, or primitive back. It's implemented in Dart, so you only need to know Dart to read it. So you go to that source file that I put on the slides and read it, and then you start searching a little bit around, and then you discover, well, wait, there is one more file like this, and there is one more file like that, and there is one more file like that, and there is one more file of that. There are 5 different implementations of the same JSON decoding thing. Well, that's where the Dart's multi-platform nature comes really and complicates things, because Dart can run on many platforms. And it does not target just native execution, right? You can run it on JavaScript or on Wasm, for example. And web is complicated. It has this JSON.parse thing, which is the fastest thing you can get on the web, but it does not give you back things that you want from it. It gives you just JavaScript objects because that's what it's made for. And if you are trying to run Dart on the web, you want to get back something different, so you need to spend time converting what JSON parse gives you, or you need to create your own JSON parse, which will be slower, and so on and so forth. So it's complicated. Life is complicated in general. So I'm not going to talk about web, because if I talk about the web, I need maybe 2 slots or 3 slots. I will focus on native for the purpose of this talk. So I'm going to talk about JSON decode on native, which is also known as Dart VM or Dart native runtime, whatever you call it. It's the thing that runs Dart on the mobile phones when you use Flutter, on desktop when you use Flutter, or if you use Dart from command line. That's the thing I'm talking about. Okay, and I'm going to put everything up front. I'm not going to hide anything because also I might run out of time, so the most important thing goes here in the beginning, not at the end. I am going to share with you my biggest secret, how I can optimize everything using 3 easy steps. So the first step, I measure things. And if it's okay already, I just go home and drink wine to celebrate. It's easy, right? If it's not, okay, I identify some unnecessary work and remove it. And then I repeat this process. Sometimes I have a break for the dinner and sleep and so on, but eventually I have not yet met a problem that I could not have optimized using these 3 steps. So this is the only thing you need to carry with you home today from this talk, and you will be okay. Okay, let's apply this to the problem of JSON decoding. So you start by making a measurement, right? So you write a small benchmark. This is Dart code. Everybody can read Dart, right? Who cannot read Dart? Success. So you have some input, you run JSON decode in a loop n times, and then you compute how many nanoseconds you spend per decoding 1 byte of input. Of course, you need to select n large enough so that actually the measurement becomes stable and so forth. I'm not putting this auxiliary logic on the slide. This is JavaScript. That does the same thing, measures how many nanoseconds per byte you spend decoding the same input. And I found a large enough file, 64 kilobytes of GitHub events, whatever the thing is, and I put it into this benchmark, and oh, it's actually, the people on Reddit are almost correct. I mean, it's not 1000x, but there is a factor of 3-4 difference in this performance here. So it's bad. And if your server really spends most of the time decoding JSON, then maybe you're doing something wrong. But in that case, it would actually come to matter. right? So if you spend 10% of your time decoding JSON, then a factor of 4 difference means that you actually could save at least 8% if you sped it up, right? Napkin math is very good. Of course, if it spends 1% decoding JSON, then you all can optimize it by 100 times and you're going to save much, right? Anyway, so does it mean we should rewrite the JSON decoder that we have in Dart into C++? Maybe, maybe not yet, right? I want to live in a world where I can speak Dart to my horse and the horse runs as fast as it can and decodes the JSON. So that's just the best world to live in. So I'm going to try to look at how we can get Dart performance on this JSON decoding as close as we can to the numbers we see on JavaScript, which uses just C++ to decode JSON. But before that, remember that recipe that I talked about. You need to figure out the unnecessary work that you are doing. So there is actually unnecessary work we are doing here that is kind of invisible. So what does JSON decoding do? You take a string, you make a map out of it. But if we stop here already and ask ourselves, where does this string come from? Is it granted to us from some revelation? No, it is granted to us in the network of some, in the stream of some bytes. So it comes from the disk or network, right? So first you get some bytes, then you decode them into a string, then you decode string into a map. That's already a bit on the nose, right? It seems like there is one step that's a bit redundant. So what if we removed this string decoding from the equation and we tried to go from bytes to map directly? In JavaScript, there is no equivalent of it. The API is just in terms of strings. But in Dart, there is also no equivalent in the API. But there is a hidden thing inside the library. It's not visible to anybody. Nobody knows about it. Not documented anywhere, maybe. But already 10 years ago or so, people thought about this redundancy. And they said, well, if you make a normal JSON decoder, well, most likely you want to decode strings. Okay, that's fine. You get a normal JSON decoder. But if you make a UTF decoder and you make a JSON decoder, and then you fuse them together, there is a method fuse on these decoders, which kind of glues two things together. Then, surprise, what comes out is not just the thing that pipes from one decoder into another. It's actually a short circuit decoder that can decode JSON directly from UTF. And they did it, but they did not document it anywhere. So when I tell this exists, people are surprised. Okay, so let's focus on optimizing these thing first. So we rewrite benchmark a bit. So we create this fuse decoder. We take now bytes as input. And we measure how long it takes to convert it. We also update the JavaScript benchmark the same way, because in V8, or in JavaScript, you would also have to decode bytes first, and then you have to give it to the parse method. So I added a function to the V8 which exposes this functionality. In the normal JavaScript API, there is no such thing. So you could use some node, like whatever, two-string UTF-8 things. God knows what methods are there, but I did something to measure. So and what we see here is that the performance on the V8, which now captures the true amount of work you have to do, it increased a little bit, like you spend more time per byte because you now need to do also UTF-8 decoding. The performance on Dart did not improve much, so it's disappointing, right? When I first did it, I was like, this really smells bad. Something is rotten. So I started looking closer. What does looking closer mean in this context? Well, it means profiling. And if you develop Flutter, then you usually profile with DevTools. I work like on my trusted Linux desktop, so I profile with perf, which is a tool that comes with Linux that can be used to profile things. It integrates with kernel. Kernel exposes underlying like hardware counters, probes, God knows what, and you can record the traces and look at them. It's very useful for low-level profiling. So I profile it and then I just look at where the time is spent. And okay, there is some parsing. It's all some English words that we can understand and digits and the sign of a %. So it all makes kind of sense. But there is one thing that is very strange here. There is the access to the uint8 list, which is a list of bytes that we have given to the decoder. It's an indexing operator that returns a single byte from it. So I would not expect that to be in the profile, because if you have to call that thing for each single byte that you're trying to read, it's not going to be fast, definitely. So the mental model which is very important to have when you try to optimize code, you need to look at the code and kind of try to reason. What operations do you expect to be fast and what do you expect to be slow? So in this mental model, I don't expect bytes access to be slow, right? Because otherwise something is fundamentally rotten in this world. So it should be some sort of an instruction sequence which it does not involve calls. It should be just some bounds checks because Dart requires you to throw an exception and you read out of bounds. And a load, not a call. But something went wrong here. So if you want to verify that this indeed the case, that actually byte accesses don't involve calls, you can try to make a small example like this in Dart, which just creates an array of bytes and then tries to read a thing from it. And then you do some incantations. You don't have to write them down in your notebooks. You can just go to slides later and check. And you look at the disassembly that you get back. And this is from the Mac. So this is ARM64 disassembly. It actually down there, right before ret, like return, there is a LDRB, which is load byte. So that is great. It actually loads the byte directly. Before that, there is a huge amount of instructions that is associated with the bounds checking. But this is what we expect. There are no calls involved here. So something must have went wrong in our benchmark. So we invoke our trusted Dart compile with more magical flags. And what that gives you is when you profile and you look at the disassembly, you can now see some comments around. So it makes it easier to read what the thing is doing. And then when you see what it is doing, you find the hottest spot, which I highlighted for you here with 25%. 25 is higher than 0.16 or 4.16, right? And right next to it, there is this call instruction. So compiler somehow failed to have access to the list of bytes, be this direct access that I showed on the previous slide. And instead decided to go with just this generic call, get me an element from any arbitrary list in the world. And that, of course, is not going to be fast. So at this point, we look at the code. And it's a Dart code, as I said, so it makes it easy for us to read. And we discover that there is this chunk JSON parser in the SDK, which is abstracting away over the underlying representation of data. There is like generic implementation of parsing, but it is not written in terms of getting a byte from a byte array or getting a character from a string. It is written in terms of calling a method of an abstract class called getChar with no implementation, which gives you a character. And then there is the whole implementation in base class. And then there are two subclasses, which one provides the implementation which reads from a string, and then one that reads from a byte array. And when I saw that code, I was like, not good, not good. So this code illustrates two performance anti-patterns in Dart, which if you want to write performant code, you should avoid. I'm not saying that you should avoid it everywhere. Somewhere it makes sense for maintainability and stuff like that. But if you are in the mode where you want to squeeze a nanosecond here, nanosecond there, this is the pattern you should avoid. You should not create base class which provides completely generalized generic implementation which uses a bunch of small methods which subclasses implement, because when you do the compilation and you end up in a situation when this base class has multiple subclasses which are instantiated in the program potentially, you end up with the base implementation which is still very generic, and it will just do calls for all the small operations that you hoped to get specialization of. And the second performance anti-pattern is that if we look back on that code, we see that it's written in terms of list of int. It uses a little bit of uint list there, but the type annotations on the code, they're just list of int. And that is also very bad. If you work with bytes, you better annotate your static types in a way that helps compiler and put like uint 8 list or uint 32 list precise type data types in the places where you work with raw data. So I made a patch in March That thing removed these two performance pitfalls from this parsing. What I did is I made a mixin instead of a base class, because mixin methods are copied when you apply the mixin. And I also changed the types in a way that say, well, I expect actually to be called with the uint8 list. Then I use this directly, because APIs are all written in terms of list of int. This is kind of remnants from God-forgotten days of Dart 1. And if I got something that is not uint8 list, then I copy, because the underlying implementation expects this uint8 list, and it will work faster if it works with u8 list. And almost nobody passes real list of int. I mean, it would be very wrong to have a list of int to represent a list of bytes, because you waste a lot of storage. Like it's 4 or 8 times larger than u8 list, right? Anyway, so when I did it, it improved it by 30%, right? So that already shortens the gap between Dart and JavaScript, and it was just a pure Dart change. I did not need to change compiler or anything. Okay, there is another performance anti-pattern here, which is kind of hidden, and in general, you should prefer to parse bytes, not strings. So it's a bit strange that we even provide that JSON parser from string as a convenience. The reason is because in Dart, there are two implementations of string to save memory again. There is like all the strings that are Latin 1 characters only. They are represented as a 1-byte arrays essentially, and all the strings that require full 2-byte representation, they represent as 2 bytes. If you write the code in terms of like just parsing some arbitrary string, compiler cannot figure out which type of string you pass. It can be 1 byte, or it can be 2-byte string, and it, as a result, cannot really produce a good code. And just you can do the same trick. You can learn how things look in the compiled code by writing small snippets of Dart code and looking at what assembly it produces. Like for example here, I wrote a code that just calls a method with a constant string, and then it asks for the first character of that string. Well, compiler was smart enough to just load a constant as a result. There is no string, there is no indexing, there is nothing, because it was just a constant string. It was smart enough. So I added a little bit of fork to hide the fact that I'm loading from a constant index. And that created more code. But the string itself, it still figured out it's always the same string, and it always just loads a byte, because that string is a 1-byte string. So you need to put even more fork in there, like say you don't know where string comes from at all. And then it produced so much code that it doesn't even fit on the slide. Like it tries to figure out what type of a string it gets, and then it loads either 1 byte or it loads 2 bytes. Okay, anyway, let's go. So that is the moral of this, even if you did not pay attention to every single assembly instruction on the previous slide, is that you better not parse strings. You better parse bytes if you get bytes. Okay. Okay, now get back to the jsonDecode. So I was reading more assembly instructions and whatnot, because that's what I like to do. I figure out that AUT compiler has some issues with ordering the machine code that it generates. And it puts the code which is not part of the loop, or like the code that should only be executed once during the loop, like for example this return or throw statements, it puts it into the loop, which is actually bad for the CPUs. So I thought, haha, if I fix that problem and I take that return block and I make it move to the end, that would improve the performance greatly. So I laboriously spent, I don't know how much time making changes in the compiler and improving this block order. The resulting code got nicer, but the improvement was hidden in the noise, maybe 5% on a good weather when there is no wind. So I went back and started reading the code, and I found the code like this. It has some switch, different characters, so it tries to parse this JSON and tries to figure out, is it white space or not? Or code like this, which it goes through the string and it tries to figure out, is it a character that continues a string, or it's a character that stops a string? This code has a lot of comparisons and a lot of decisions happening to it. So maybe there is a better way to write it. So what it's trying to do, read the character and categorize it. Is it a white space? Is it something else? So the solution for this problem is to use a lookup table. You can make a table for each possible character. There are 256 different bytes, right? You can encode this information to that lookup table. Is it a white space? Is it not a white space? So on and so forth. And then you can use a single thing to write that whole loop. So you basically go through the whole string and then check, is it the end of string? And this covers many different characters in one go. And there is some magical string. That's how it looks like to categorize these characters. Does not matter. There is an explanation I will skip. Anyway, so it helped a bit, but I discovered that the compiler still struggles with that code. So for example, this if condition, it was producing bad code. It should be just one instruction on the Intel CPUs on ARM64, but it was not. And then bounce checks, which I showed before, they are actually causing issues already at this point because the loop was getting so tight. And there was some other overheads in the loops that were also causing issues. So I landed more changes. And that improved by another 30 to 40%. So I removed some bounce checks. Okay, I'm cheating here, but it's inside the SDK, so you don't know about it. I improved the compiler, and finally landed change that used this character attributes map. So, and then I looked at the profile again, and things started getting very flat. So now the overhead is spread across the whole parsing implementation. And but there is a lot of stuff that deals with hash maps because you produce hash maps. And I looked at that and I realized that the hash map is being built one key at a time. So you rehash the map periodically if it reaches the capacity. That takes time. So I landed another change which also gave some improvements that basically as you go through the map, you count the keys but don't hash it immediately. And then you go in one go and you produce the map of the known capacity. And that got us to 3.5 nanoseconds per byte. So we're still 30% slower, but it is a huge improvement from where we were before. And if you look at the bigger corpus of benchmarks with JSON parsing, we see that somewhere we're even faster than V8, like 84% of the V8 performance. Somewhere we're pretty close. Somewhere we're still slower. So I was looking more on this, and there are different possibilities to optimize it. You're getting into really obscure things, and complexity starts skyrocketing. So I thought, maybe I need to rethink this. And yesterday, 3 in the morning, I was rethinking this. And I applied this. So the fastest piece of code is the one which does not need to run, right? That is the thing. So there is this C++ library called cmd.json. It's written in C++. And now so I exhausted the Dart things. Now I'm going back to the C++ things. It is a very cool library. It uses cmd, which is the single instruction multiple data CPU stuff, to blaze through the JSON. You give it many characters at a time. Because in Dart, I'm forced to do one character at a time, categorize, move to the next character. With cmd, you can do many, many characters at a time. So, and it also has this capability of doing lazy parsing. So if you don't ask it to give you a specific key from the map, it just skips that key completely, just finds where the, for example, closing brace is, and off it goes. So it goes very fast. What if you use it in Dart? And we are coming here to the conclusion. I don't know how much I overrun, but anyway, I want to finish. Once in a lifetime, I'm not going to stop. You can take this from my cold hands. Anyway, so yeah. I created a simple Dart package, and I will actually publish it on GitHub at some point, maybe tomorrow. The famous last words, so in a year you will ask me why it's still not published. And then in that package, I put the cmd.json library. It's just a header file and a C++ file. They're just 2 files. I put it in the source. And then I made this hook/build.dart file. Who knows about that file? Well, you are too advanced. Almost nobody knows. Yeah, and you're like, what the hell is that file? Never heard about what this hook here. What is that secret technology? It's something called native assets. If you have not heard about that and you have to deal with native code, I suggest you hear about it now. It's a thing that we try to revolutionize. No, we try to streamline the way you add native code to Dart packages. So you don't need to deal with strange Flutter plugin templates and Gradle and CMake and God knows what on Apple stuff, Cocoa Pods, deprecated Swift, whatever, doesn't matter. So all of that goes away. Instead, there is this Dart file there. And before we get to that Dart file, so you make some simple C code, for example, like this, which uses SIMD-JSON API. Okay, you put it in the C++ file. You make a simple Dart code which says, well, I have that function somewhere. It's external. It has this Dart signature and it has this native signature. Please hook it up together. And then you make this hook build.dart file which says, I have this library which has this C++ code inside and it has this compile flags and it's written in C++. And that's it. Then you run Dart enable experiment native assets, you run that Dart code, that would build C++ code magically transparently underneath. And it would just run. If you run Dart enable experiment native assets build, it would produce an AUT compiled code, which also has next to it all the compiled native code from the C++ libraries you included. And it's made extensible, so it can be Rust, it can be Go, it can be whatever. You can provide different extensions to that build system. Anyway, so I used it. Then I made some things. Doesn't matter. You can go to the thing, read it later. So what I did is that I looked again at this thing. We removed string and we go from bytes to map directly. What if we think about the next step? What happens to the map? Well, map you usually pass to X from JSON and you make real objects from it. So maps are also, just like string before, they are intermediary objects to create real objects from them. So what if we remove that step? So what if we just take a list of bytes and make normal objects from them? And I wrote some code, and I wrote some more code, and it does not matter, but I've skipped this. There is a bunch of low-level stuff. I don't want to go into detail. You don't have capacity to understand it right now anyway. You're like thinking, coffee. So it would be nice if it was all just hidden, if I could write macro. I was sitting there at 3 in the morning and trying to write a macro, discovered there are bugs that prevent me. There is, we don't support augmenting fields, for example. So I could not write it as a macro. So I just made my own DSL in the night. And from this JSON description of my tweet feed layout, I generated a bunch of Dart code. And magic! It now can parse this. It's a different JSON file, but before it was also quite slow on the same JSON file. It's actually the one that is slowest to parse with Dart now. And now it's only 1.6 nanoseconds per byte. And it parses everything still. But here's the thing. So that benchmark just parses everything, creates Dart objects from the things, but it doesn't actually access any of the data. So as a compiler engineer, I always think, well, it would be actually good to screw this program up and not parse any data. And TreeShaker actually knows that you're not calling any getters on these methods, on these objects that you create. So you're not accessing any data, but it does not give this information to SIMD JSON, which is responsible for parsing the JSON. So it dutifully parses everything that I asked it to parse. So, but it turns out, hidden in the Dart SDK sources in the MD file, there is a magical pragma, which we created specifically for this reason, because we were thinking about, for example, protobuf deserialization, how to tree-shake parts of the protobuf deserialization code, which is responsible for parsing protobufs that are never accessed. So we created this VicTROFs, and it doesn't matter how it works, but it works. So I changed my generated code to check if a user is actually, if the user code is actually accessing the specific fields. And if it is not accessing it, then I tell SIMD-JSON not to parse it. I just skip that thing. And it sped it up even more, because now it does not actually parse anything, because it just churns through this JSON and then says, whoo, and it just counts how many, for example, tweets are there. So it loads that information up, but all the contents are absent. But then if you, for example, start accessing created at date, then only that field will be parsed in this setup. Yeah, okay. So now closing remarks from this. What do you need to learn from this talk? You better have a mental model if you're trying to optimize things. If you don't understand what you are trying to optimize, you cannot really make any improvements, right? Okay, that is a truism. That is too banal. you need to look for things to stop doing. Like everything that I have done was about removing things that are unnecessary. And when people, for example, come to me and ask, well, my code is running slow. Well, you're doing list.expand.map.reduce.toList. And this could be actually written in 3-line simple for loop. And then you write it like that and it's 100 times faster. Well, maybe you could hope that compiler can do it for you and for you file issue about it. But you can also spend just 3 minutes rewriting that super high-level code to a slightly less high-level code, and it would run much faster. Maybe jsonDecode is now in the current SDK, after all these fixes, is actually doing all right. Like 3 nanoseconds per byte is 300 megabytes per second. Maybe your server does not need to parse so much JSON. I don't know, is it like TikTok encoded in the base 64 and that base 64 is put in the JSON and streamed to your server? I don't know. So maybe you should give Dart on server a try if the jsonDecode was the only thing that was stopping you from it. And also, I know I would like everybody to write as much Dart as possible, but with features that are coming now down the pipe, like native assets, you can do pragmatic amalgamation where you amalgamate Dart with your other favorite language. I would prefer that Dart still is your #1 favorite language, but if your #2 favorite language is C++ or Rust or Zig or Pascal or whatever Asian, anyway, so yeah, so. But don't reinvent the wheel. Reach out for the native assets and embed them into your package. And that's the last slide. I will stop talking now.